Okay, our lecture today comes from section 4.9, Rotations and Perpendicular Lines. Now this section should sound a little familiar in that geometry you spent a lot of time with perpendicular and parallel lines. So you can see we're going to be doing some things with images, shapes, but let's move forward and see what they are. Dealing with matrices. So some review info. Please make sure you take a look and you understand each piece separately. So first one, if two lines with slopes m1 and m2 are perpendicular, then you should be able to multiply those two slopes and get an answer of -1. Next, if the two lines have slopes m1 and m2, and they do multiply together to equal -1, then you know the lines are perpendicular. So they are sort of inverse situations of each other. Also, you should have learned the phrase that slopes are opposite reciprocals of each other if they are truly perpendicular. So an example of that is, if I have one line that is a slope of 1/2, the other line would be a slope of -2. If we use fractions, if I have a slope of 5/3 for one line, then the slope for the other line that is perpendicular to it would be -3/5. So opposite sign and reciprocals, the flip of the number, think of it that way. Also, we had our rotation of 90 degrees, which means perpendicular. You know in geometry, if you have two lines that are perpendicular, they formed a 90-degree angle, which means our rotation of 90 degrees, which means our 0, 1, -1 matrix. And also, it means if I have a point xy, then my rotated point should be switch x and y positions and turn the y value to its opposite. So it would read xy becomes the opposite of yx. So with that, one other thing from geometry we're expecting you to remember for this section is the midpoint formula. So with the midpoint formula, think of midpoint as middle, and if I do middle, then I'm thinking averaging, and when I average, I get the two x values added together, divided by 2, and the two y values added up and divided by 2. So it's like averaging two scores, but that's how you find the actual midpoint of your segment. And we will definitely have to do that in our work today. So let's start with just some questions. So based on all those facts that we know about parallel and perpendicular lines, determine whether the lines with the following equations are parallel, perpendicular, or neither. Now, you truly could take these equations and rewrite them, get them y by himself, graph them, do all of that. But we have some shortcuts that we definitely want to be using. So to start with, on this first one, if we say, let's find the slope, because that's, in order to say I'm parallel, I'm perpendicular, or neither, we're talking about the slope of the lines. So if I have the slope and I say opposite of A over B, I would have the opposite of A is -2 over B, -4. You simplify that and you get 1/2. So in my first line, we have the slope of 1/2. Go to the second line. Same thing, opposite A over B is my shortcut. And we would take the opposite of A is -1 over B, which is 2. And so we get a slope of -1/2. If I got a positive 1/2 on the first one and a negative on the second one, they are not parallel, because parallel lines need to have the same slope. And perpendicular needs to have opposite reciprocals, and these guys are just opposite, so that doesn't work either. And so we'd have to say neither. These lines are neither parallel, perpendicular, which means they could be just intersecting. Okay? And I think we're good, except for I do see a mistake I made right here. Opposite of A over B, B was a negative 2. And so if we get negative over a negative, that comes out to be 1/2. And we can say, when we do the correct choice, that these are parallel because we do have the same slope. So see my mistake? Opposite of A was negative 1 over B, which is a negative 2, and a negative divided by negative is a positive, so we get a 1/2 for both. Okay, so got that cleaned up. Moving forward. Line L is defined by this equation. Line N, though, contains the point 38 and is perpendicular. So we know we need to have opposite reciprocal slopes. So it says find an equation for line N. So the first thing we better do, carefully, is take the slope of our current line. So the opposite of A, negative 5, over B, which is 4, and therefore we would get a slope of negative 5/4. From there, that's the slope of this line, which is line L. Okay, so that would be, maybe just say line L. So now we need the slope of line N. And remember, the slope of line N, because they are perpendicular, has to be the opposite reciprocal. So brain says the opposite would be positive, the reciprocal would be 4/5. So our perpendicular slope, which we need, is 4/5. And our point of 3/8 they gave us, so we, I think, are ready to go. We have our two pieces. Look carefully at what they are. One is a point, one is the slope, and we're going straight for point slope form, which we should know as this. And so let's put our values in. We have our point 38, so it would read y minus 8 equals our slope 4/5 times the quantity x minus 3. We could stop right there because it just says write an equation, so it's any equation. However, we could go to standard form if we need to. We could go to slope-intercept form also. But we have one, so we're good. There is the equation for line N. Next, find an equation for the perpendicular bisector of a segment joining A, point A, negative 6, 7, and B, negative 8, negative 3. Now on a regular coordinate graph, if we would just visualize where we're at here, if I said I'm at negative 6, 7, we'll go up there about, we'll call that point A, and then I'm at point B, which is negative 8, farther out, negative 3, so down here is point B, we're talking about I need something that is the perpendicular bisector of that. So it's not a slant, it's not easy to look at, to visualize, so there's two things we need to do. First, we need to find the middle of this segment. The middle would be the midpoint. So let's take our values and do the math. Remember, we have a midpoint formula which says take the x's and add them and divide by 2. Take the y's and add them and divide by 2. When you simplify that, negative 6 plus 8 is 2. 2 divided by 2 is 1. 7 plus negative 3 is 4. 4 divided by 2 is 2. So we get the point 1, 2. That would be the middle of that section, of that segment, sorry. And again, that's assuming we graphed it correctly. So if that's the middle, check my points again. We have a problem. Math is bad. The x value is a negative 8, so negative 6 plus negative 8 is negative 14, divided by 2 is negative 7. Didn't have to make that much of a change. Check the other one. 7 plus negative 3, that's a 4. 4 divided by 2. So now we're looking at a negative 7, 2. And that makes a better choice. If we came over here, we're at negative 7 up to, so maybe right about there would be the midpoint. From there, we need to find out what the slope of this line is. So the slope of our current line is equal to y minus y over x minus x. Again, do the math. 7 minus a negative 3 is 10. Negative 6 minus a negative 8 minus a negative would be plus a positive is a 2. So the slope of our current line is 5. But we need the perpendicular slope. And that would be the opposite reciprocal. So we need negative 1/5, and we also need this midpoint value, and we're ready to write our final equation. Again, because they did not say in what form, I'm going to go for point slope, because here we have our point, here we have our perpendicular slope, and we're good to go. So y minus our y value equals our slope times x minus a negative 7 will be plus 7. There's our equation for a line that would be the perpendicular bisector of this segment AB. Looks good. So all types of questions in regards to perpendicular. The only thing we have yet to discuss is what about if we take a shape, what are the characteristics about rotation? So, rotating something 90 degrees. We're going to use a couple math tools here, and we are going to take this rectangle and talk about its characteristics if we did rotate it 90 degrees. So, let me put another one up here right on top of it. And so we've got them matched up here, and let's take this top one and let's spin it. Rotate it 90 degrees visually. Now, question, I think that'll about do it. So if we have those two shapes there, did the shape change? No. Did the edge lengths change? No. Did the angle measures change? No. So what changed? Some people would say the perspective of the shapes changed. We are still not looking at the same view of the rectangle. You're going to say, wait a minute, what are you talking about? Well, if we would come over here, and originally the A, B, C, D was here. Now think about what happened. This is now A. Our B value is here, C is here, and D is down here. So the orientation of the letters is not the same as it was before. Lower left-hand corner was A. Lower left-hand corner is no longer A. And it doesn't matter what shape it is that you move, the orientation is changing. Size stays the same, shape stays the same, angle measures stay the same, edge lengths stay the same. So these are characteristics you must recognize. We've been listing them as we go along for all the different ones, and that's what we're expecting here as well. And I think no matter which shape we use, whether we use my triangle, my arrow, whatever, you're still going to say the same things. Now we're only talking about a rotation of 90 degrees. So you should be able to graph something. You can even remember, use our shortcut ordered pair for XY rotation was if you have any point XY, it will turn into the ordered pair opposite of YX. So if I gave you ordered pairs and I said rotate it, and you're not good visually rotating it, then using our shortcut would be good. You could also multiply it by our 2x2 matrix. So we have several different choices. So perpendicular and parallel lines, a lot review from geometry, but we add a new component from algebra as well, talking about the characteristics of the shapes, the edges, the angles involved in our work. So that's all for today. Bring any questions you have to class.